All right, let's talk gases and stoichiometry. I'm taking my tablet apart. Here we go. Sorry, I hit play before I was ready to go. Rookie mistake. All right, so stoichiometry. We have to understand mole maps. We have to understand mole bridges. We just added this week volume of a gas to our mole map. And we know that at STP, if you have 1 mole of a gas, it will have a volume of 22.4 liters. Or if you have 22.4 liters, you'll have 1 mole. That's 11 and a little bit more 2-liter bottles, if you want to think about that. Okay? So, we can add that in to our mole bridge. We can add in a volume of gas, and I'm going to put at STP here because that's important. You multiply by 22.4 liters per mole. Okay? And again, if you're solving for the gas at STP, you can divide by 22.4. You might think you need to use the whole PV equals nRT, and I'll show you why you don't, because everything cancels itself out. If you are going from a gas to a gas at STP, you don't even have to convert it if you're going back to a gas. And I'll show you that as well. All right. So let's first look at this gas stoichiometry practice worksheet. We're going to use this equation. I'm going to rewrite it at the top. For all of these problems. Okay? It says how many liters, and we're making liters of gas, of water can be made if you have 5 liters of oxygen gas and excess of hydrogen. So we're starting up here, well, down here. Should have just put it on its own page. We're going to start here. All right. Oops, that's the right answers. We've got 5 liters of oxygen. First, we have to convert it to moles. To go liters to moles, I'm going to use this guy. If we're going to go liters to moles, we have to divide by molar mass. Not molar mass, molar volume of a gas. 22.4 liters in 1 mole. All right, that's taken us to moles of oxygen. My ratio of moles of oxygen to moles of water is 1 mole of oxygen to 2 moles of water. And then it wants to know the volume of the oxygen. So what we've done on our bridge, we've gone from here to here. We've gone across our bridge, and now we're going to go back, and we're going to do that by dividing by the molar volume, or we're going to multiply. That bridge is wrong. I just realized that. This should be divided here, and this should be multiplied there. I'll make sure I get that fixed. So we're going to multiply by 22.4 liters of water for every 1 mole of water at STP. Okay, liters are what we're going to solve for. Moles cancels, those liters cancel. Now, do you notice anything in that equation that's the same on both sides, only on opposite sides of the rail fence? If you look, we divided by 22.4 over here, but on this side we multiplied by it. So didn't we cancel itself out? We did. So really we're just talking about 10 liters. Do you have to divide by 22.4 liters to start and multiply back? No. If you're working at STP, and if you're working at gases, you're calculating the volume of a gas from the volume of a gas. Both ends of your problems are volumes of a gas. You can just skip that step. It's just amazing. You can go 5 liters of oxygen times the mole ratio and you get 10 liters of water. Same thing. If I plug this all into the calculator, same story. So let's look at this one. Now, can I do that here? No, because I'm starting with grams. 55 grams of oxygen gas. And first I have to change that to moles, so I'll divide by 32 grams and 1 mole. My mole ratio is 1 mole of oxygen for each 2 moles of water. And now we need to change it to liters. So what do? Looking back at our bridge, we're going to multiply by the molar volume of a gas. Now, I just got done saying that we didn't have to do that if it was at STP. But what's the difference here? We started with grams and we're ending with a volume. Up here we went volume to volume. All right, so we do have to multiply by 22.4 liters in 1 mole. And to do that, I've already done the math. You get 110 grams, 77 liters. All right, number 3, this time we've got some different information. And we're starting once again with grams. 55 grams of oxygen, 32 grams and 1 mole. 1 mole of oxygen. We're solving for water. 2 moles of water. But we're not at STP, so can I use 22.4? No. What I can do is use PV equals nRT. All right, I'm going to do this 2 ways. The first way, I'm going to say, all right, well, let's solve for this right now. 55 divided by 32 times 2, which would help if I turn the calculator on. We get 3.44 moles of water. Now, we know moles, we know pressure, and we know temperature. We're solving for volume. PV equals nRT. If we're solving for volume, we're going to go nRT divided by P. So we're going to take 3.44 moles of water times the gas constant, 0.0821 liter atmospheres over mole Kelvin, times temperature, 85 plus 273. Don't forget to convert that. That's very important. And divided by our pressure, so I'm going to put that down here, 12.4. Ooh, that's a high pressure, atmospheres. Plug and chug. So we'll multiply 3.44 times 0.0821 liter atmospheres times mole degree Kelvin times 358 Kelvin divided by 12.4. Moles cancel, Kelvins cancels, atmospheres cancels. We have an answer in liters, and our answer is 8.15 liters. Okay? Now, I said that we can actually smush those two together because this value here is equal to 3.44. So, through the magic that I have, because I am magic, I can do that. Can't read it, so let's bring that back, and let's erase that. And now, isn't that cool that it makes that little Z, that little circle? And we got, what was it, 3.15? 8.15. We don't need this in here though. That's all we have to do. All right, this next one's a limiting one. 34 grams of oxygen gas, and we're solving for liters of water. But we also know that we have 6 grams of hydrogen gas. So first let's solve for liters using the oxygen. 34 grams, molar mass of oxygen is 32 grams per mole. We're going to have 1 mole of oxygen to every 2 moles of water. And we're at STP, so we'll multiply by 22.4 liters in 1 mole. Hydrogen, the molar mass of hydrogen is 2 grams in 1 mole. 1 mole of oxygen, no, we're in hydrogen now. 2 moles of hydrogen to 2 moles of water times 22.4 liters. When I did the math out, 47.6 liters here, 268.8 liters. What does limiting mean? Well, limiting is talking about what's going to make the smallest amount because it'll get used up. If we make hydrogen, we're going to make a whole lot of water vapor. Oxygen's not going to make as much. So oxygen will get used up before we can make that huge amount with the hydrogen. Hydrogen will be left over, and our answer is here. All right, so that's a little bit on stoichiometry with gases. So now what I'd like you to do is work on this one. And this one is starting with mass every time over here. So you're not going to be able to do the shortcut ratios of gases like I showed you with that very first one. So for this one, you're going to start with grams, and you're either going to solve for pressure or you're going to solve for volume. So you've got your 3 steps. You're going to change grams to moles, go over the mole bridge using the ratio, and go back to either pressure or volume. Okay? If it's STP, do you have to do that? No, you can actually put in 22.4. So if it's at moles unknown at STP, and that will give you liters. That won't give you pressure. You'll have to still use it for pressure, but you can calculate liters that way. All right. Good luck.